Hello, this is John from caveofprogramming.com. In this video, we're going to take a look at suspending functions in Kotlin. Kind of a strange term, but it basically means functions that we can suspend. So I'm creating my project in a way that I usually do, and I'm using IntelliJ IDEA, and I'm just going to use the default build system for IntelliJ. You can also, as we've seen previously, at least we've talked about it, you can use Maven or Gradle to add the library that you need for coroutines. I'm just going to click Create. I'm going to say that I want to do this in this window, and I'll go to File, Project Structure, and we'll go to Libraries and click the plus to add a new library from Maven, and I want to add Kotlin x-coroutines-core, as we saw in the last video. So I click the search button there, and when the list comes up, I'm just going to add the latest version, which at the moment is 10.2 from org.jetbrains. So I click OK, OK, and OK. And now we've got a project where we can use coroutines. So I go to New Kotlin class or file, and I'm going to just create main.kt, which is what I usually do, and select File there. And then, of course, we can have a main function in there, and all of this is stuff that we've been over previously, in some cases many times. Now, one thing that I want to show you is just a little bit of syntax before we get started that we haven't previously covered in this course, and that's if I type repeat here, we've got a kind of function that can accept a trailing lambda. I can, for example, repeat 10 times, and I'll put a couple of curly braces in there, and let's just put print line hello or something, and that's just going to do exactly what you might expect. It's just going to repeat this code 10 times. So when I run it, we are going to see 10 hellos coming out in the console. We're going to make use of that in this video. So previously we've seen that if I write launch here, I can put some code that will run in its own coroutine. So let's maybe just here, let's just put a print and just output nothing but a dot, and after that, I'm going to put print line, and we'll put main finished down here. So if I hover over launch, because I've already added the library to my project, I can import launch here, but I have forgotten something. Maybe you can remember what. And if I try to run that, it's at the moment not going to work, because we have to use launch in a coroutine scope. And one way to do that is to write equals run blocking after main here to create a coroutine scope. And now everything we add in launch is going to run before the main function will actually return and the program ends. So let's run that. And we can see that we've got just a dot coming out down there in the console. So coroutines are very lightweight. If I want, I can put this in a repeat, and I could repeat this lots and lots of times. For example, 10,000 times. Let's put this in here. I want to put 10, what am I doing? 10,000 here. I've suddenly got like a mental block. That says 10,000, right? And I need to put brackets after this. And I can move the launch into there, and we can launch 10,000 coroutines, at least if I remember the right key shortcut, which is actually Option Shift on the Mac and the up arrow. I can move that into there. Let's indent it a bit. And now we're going to launch 10,000 coroutines. I'll put a delay in there as well, so that they can kind of work around each other rather than just kind of locking up my CPU. So let's put in delay, and we'll have a delay of maybe a second, so 1,000 milliseconds. And we have to hover over delay and import the delay function, which is from Kotlin x.coroutines, and this should all work. So what I expect to see is main finished is going to come out first, because this whole thing's going to execute before these coroutines manage to get started, and then we're going to see 10,000 dots. So if I run this, we'll just see a long line of dots, which is right here, and you can see, I think you saw there, that we got main finished coming out first. And one thing I can do here is repeat actually passes a parameter to its lambda, and since it's just one parameter, I can refer to it using just it. And I could put that, for example, here, and I could say if it, and that's actually the number of the iteration. So if I say if it maybe %50 equals 0, so every time the iteration number reaches a multiple of 50, then we can just maybe output a new line, and that will make the output look a bit nicer because we'll have each row will be no longer than 50 characters. So if I run that after the coroutines actually launch, then we get this sort of block of rows of 50 dots. Now, what if I want to do this stuff in a separate function? Let's try that out and see how it looks. So if I write fun, let's call it printer down here. And so I'll put round brackets there, curly brackets. And we want this launch stuff, including the repeat, to all be down here in printer. After it's finished, let's do print line printer finished dot. And maybe just to make the output look a bit nicer, I'm going to put a new line before this main finished and a new line before printer finished, so that stuff doesn't just run onto the same line. And you can see here that we've got a problem. This program is not going to run, and it's not going to run even if I call printer here either, which is what I want to do. But we have got a problem down here. I can't just use launch from any old function. It has to be used in a coroutine scope. So what I could do here is I can say fun printer equals, and now I don't want to use run blocking. Let's just try it though and see what that actually does. So I try putting run blocking there and run it, and it does actually work. But we shouldn't normally actually do this. What we want is, instead of run blocking, we want to write coroutine scope here, and that establishes a coroutine scope for our printer function. So I need to hover over that and go to import function coroutine scope, and we've still got an error because now we have to mark this function with suspend, and that says that it's a function that can be suspended. So it's a function in which, for example, we can have a delay which will allow other coroutines to run. So now finally we've moved all our launch code into a separate function, and this is the normal way to do it. And that separate function, which we're calling here, is going to launch how many? 10,000 coroutines, which are all very lightweight, so we can easily do that. And if I run it, and if we look at the output here, you can see that the first thing we've got is actually printer finished. So this function is not going to return until all of these coroutines have actually finished doing their stuff. But everything at the top level in the function gets immediately executed. So we're running that, which is starting off the coroutines, but then immediately we go on and we output printer finished, and then the whole thing waits until all the coroutines are finished. And only after that, so after we've got all the dots, only after that do we get main finished, which is therefore coming out at the bottom down here. So the sequence of it is important to understand, and it's a little bit counterintuitive. But it's worth trying this out so you see how this actually works. What if we actually wanted to wait for all of these to finish and only then output printer finished? Is there a way we can do that? And in fact there is, using the idea of a job. So I'm going to collect job IDs from all of these coroutines, and I'm going to use those to wait until all of the coroutines are finished. So let's have a list up here. Let's say val jobs equals mutable list of, and I'm going to have to specify the type because I haven't got anything initially to put in it. The type's going to be job with a capital J from kotlinx.coroutines. And then when I call launch, I can actually get a kind of job ID or job handle from launch like this. It actually returns that, and I can add that to my list of jobs. So jobs.add job. And then after this repeat block, I can loop through them and call join on all of them. So I can say for job in jobs, and then all I want to do is say job.join. And remember, join is just going to wait for that coroutine to finish. And what this achieves in the end is that all of that's going to execute, then all the jobs are going to finish, and we're waiting for them all to finish with join on each one until we output printer finished. So let's run it. And now you can see, so the order's a bit different. We've got a load of dots here. Let's scroll to the end of the dots and see what's there. And at the end, we've got printer finished, and then we've got main finished. So remember, this printer function is going to execute all of its coroutines. They're going to run to completion until this returns. And since we're waiting for them all here before we output printer finished, that's going to come out, and then finally this function will return, this suspending function, and we'll get main finished coming out down here. We'll carry on looking at this more in the next video. Do let me know if this is useful or not, or if there's anything you'd particularly like me to cover here. I'm open to ideas. So until next time, happy coding.